Welcome back, all 378 of you. I bet you're all gagging to see if the wiring I did in part 1, link in the word box below, has finally burnt down my shed. I've got answers to all that and more. Apologies for the delay, let's just say it was due to some ex-wife related data loss. Anyway, part 2 has arrived and today I'm going to share some tips to help you look like a proper daddy when it comes to installing sockets and switches. I'll dish out some basics of electrical testing and I'll even throw in how to safely isolate electrical circuits, because nothing ruins your day faster than turning yourself into a human light bulb. Hello lovely people, welcome back to Fixing Rusty Stuff, where the fun never starts and the work never ends. These videos are purely for entertainment purposes and are not instructional. Now some folks think that only qualified electricians should do electrical work, and while that's definitely the safest bet, technically any competent person can do it too. The trick is knowing if you're one of those. So before you even think of touching a screwdriver, ask yourself, do I know what I'm doing, or am I about to find out how dark it is 6 feet below ground level? If you don't have the correct knowledge, training and experience, you should never ever piss around with electricery. With that being said, let's start pissing. The first and most important step in any electrical work is safe isolation. According to the IET, our fancy electrical overlords, isolation is defined as a function intended to cut off the supply from every source of electrical energy. In plain English, stop the circuit from waking up and choosing violence while you got your finger burgers wrapped around bare wires. Now let's have a look at the steps. Obviously, the first thing to do before making any isolations is to safely shut down all your sex robots, or you'll spend ages reconfiguring them on your next use. Step 2. Identify the circuit. In my man cave is simple. I'm killing all the circuits. And that means I'm flicking that big fucker on the left. Step 3. Switch it off. Simple enough, flip the switch. Even your dog could do it. But don't let them. Dogs don't have opposable thumbs and are known for being very clumsy when it comes to electrical work. Step 4. Lock out, tag out. Now we're getting serious. This is where you slap on a padlock and tag the switch, hopefully preventing Sandra from flicking it back on to make you a cuppa while you're wanking off a 6mm cable. If you're watching, Sandra, thanks for the cuppa, but that f***ing hurt. I'll use this unassuming MCB locking device. It costs about a tenner, but it's worth it to avoid one of those trendy 230 volt hairstyles. Step 5. Test it. Here's where we cross our fingers and hope we did the other steps right. I'd also recommend testing at all points of work just in case you completely f***ed up step 1. Identify the circuit. Anyway, for this you'll need an approved voltage indicator, or AVI as the acronym loving pros call it. Here's the deal. First, give the proving unit a double hole pumping with the tester to make sure it's definitely working. No, it's not overkill, it's called not trusting cheap gadgets with your life.
Oh, baby.
If it lights up or beeps, it's working and you're good. Next, test the circuit. Line to neutral, line to earth, and neutral to earth. If the tester stays quiet and don't light up, congrats, you've officially anaesthetised the circuit. Finally, test the tester again, because if it stopped working mid-test, you might be pissing out lightning bolts on your next trip to the little boy's room. And I don't know about you, but my dick's shocking enough already. Once all that's done, you're golden. Always remember, safe isolation is better than an unsafe explosion. And nobody likes crying out of their burnt and crispy vagina in front of the boys on site when they get a stinger. Now that I'm safely isolated, it's time for sockets. But before that, I feel it's time for a full disclosure. Now the reason I lost all my video data, delaying this episode, is because my ex-wife called recently and demanded that I take all the saucy photos we took together back to her house in Islington. I was working away in Scotland at the time, and I told her it would be hard to drive. She must have misheard me and thought I said they're on my hard drive. Consequently, she came round and smashed up my computer and hard drives, along with all my other electronic equipment. I got the last laugh though. I've still got those saucy photos, and they'll be making their way onto the interwebs very soon. Anyway, I've had to scrape this episode together using the remaining footage still left on my camera. I'll recreate the original footage using a dummy back box and cable. Sockets are the most basic electrical item to install. Usually you'll have 2 cables in a socket box, unless it's got a spur, which will have 3, or an end of line which will have 1 lonely cable sitting in the back box like a 50-year-old cat lady on a Saturday night. To strip the cable, make a nick at the top with your cutters, and, reminiscent of a virgin having his first wank, grab hold of the earth wire, or CPC as the pros call it, and yank it up hard through the insulation. If you've done it right, you should now be able to peel open the cable like a banana to reveal the line and neutral wires. Now, complete an engineering circumcision by cutting off the excess insulation with your side cutters. The socket terminals will be labelled with L for line and N for neutral, so there's no excuse for putting it in the wrong hole like that time you really pissed off your ex-wife.
You're damn right it was a mistake fixing.
I like to move the cables over to their corresponding sides to make it neater and prevent the crayon drawing look. Let's earth the back box. Grab a bit of earth cable and poke it into the earth terminal on the back box, tightening up the screw. Sleeve the other earth cables and connect them to one of the earth terminals on the socket. Chuck the back box earth into the other earthing terminal on the socket, and now everything is connected to the main earthing terminal on your fuse board for circuit protection. Strip the line and neutral cables just enough for the screw terminals to make good contact with the wire, but not so much that you got a shit ton of bare cable sitting in the socket waiting to electrify any nearby conductive parts. A general rule of thumb is that if you can still see copper after you've terminated the socket, then like an old age pension lap dancer, you probably stripped too much.
I can't twerk anymore, but I can wobble with the best of them.
Now the fun part. Give the socket some double penetration with the cables. It's like you and your best mate double teaming your favourite brass, but with zero STDs and a significantly lower price tag. Tighten the terminals and give it the old tug test, insert joke here, to make sure you got a good connection. Finally, ram everything back into the back box and screw it back, preferably without the cables trapped under the faceplate screws. Your socket should now be on the wall, hopefully looking sexier than your last Tinder date. Okay, now for the slightly more complicated installation of the light switches. Don't worry, it's not as tricky as convincing your ex-wife that a divorce settlement check is in the post, but it will require an explanation. When a switch is in the on position, the electricity flows into the common terminal and out of the L1 terminal to the lighting point. When it's switched off, the switch lever moves over to the L2 position, which has no cable connected, and the electricity is basically an electrical equivalent of carrying on lockdown. It stays in the switch and doesn't go anywhere.
This is the second time they're out today. Send the police, quick.
Okay, not exactly like a lockdown, Karen. Don't forget, the terminals are reversed when you turn a switch around. The method I wire in is always 2-plate. Anyone who's anyone wires in 2-plate. The other method is 3-plate and it refers to the number of terminals used at the lighting point. There are various advantages to 2-plate lighting, but the main one, for a lazy cunt like me, is that the feeds are terminated at the switch, leaving less cables to terminate at the light. And if you've ever had to screw something above your head for more than about 2 minutes, you'll know what I mean. Consequently, a 2-gang switch will have 4 cables in the box. A feed in, a feed out, switch line 1 and switch line 2. You'll also have a wire between the 2 feeds to replicate the loop terminal you'd have at the lighting point in 3-plate. And yes, I have excluded the earth and neutral cables here for clarity. As you can see, I labelled the cables so I don't have to play guess the wire. Strip the cables and circumcise the insulation the same way you did the sockets. First, the earths. Throw on some earth sleeving for a decorative flair. Throw them in the earth terminal and tuck them away neatly at the back. I've got a lot of room here, but that's not always the case. Let the neutrals all have a gangbang in a connector block and dress them in next to the earth nicely like you're prepping them for a family portrait. Make sure the connector block is rated to at least 6 amps though, or she might not be able to handle all those electrons getting pumped through her hole by the neutrals.
I don't think our hole's big enough for us boys.
If you were careful, you've marked your feeds and your switch lines with a Sharpie pen, so you still know which one's which. Now whenever there's only one cable in a terminal, I always fold the end over, because copper's got about as much backbone as a Labour Party politician.
My dad was a toolmaker.
And those screw terminals will crush copper faster than my ex-wife crushes dreams. These multifunction CK side cutters do the job lovely. Time to terminate, so channel your inner Schwarzenegger, but hopefully with fewer explosions and more careful wire handling. First, chuck a feed into each common terminal and link them using a small piece of brown cable. Now figure out which switch you want to control which light. Remember, you'll be looking at the switch from the back, so it'll be reversed. Throw the switch lines into their respective L1 terminals and make sure everything's as tight as a virgin's arsehole. Give it the old tug test to check and slap the switch plate back on the wall with a couple of beloved 3.5mm screws. After that, light installation is simple. Brown to brown, blue to blue, and the earth slammed into the earthing terminal like it was always meant to be. I put up 4 pendant lights currently, although I did wire enough for about another 6, plus bar lights for the as yet unbuilt bar. I might change them to downlighters or some homemade deaf lights in the future, but this'll do for now. In total, I wired about 20 sockets, which is almost enough for all my sex robots. I also wired 3 2-gang light switches, 1 output for a heating circuit, which is currently a plug, and I also ran an HDMI cable up the wall and through the ceiling for the projector. Overkill? Definitely. But is it worth it? Not even a little bit, but I did it anyway. I also threw on those antique deaf lamps from a restoration project video, and chucked on the floodlight on the side. If you're still with me, we can now officially crown you King of Sockets and Switches. But don't get too smug, Your Highness, it's testing time. And now, time for a brief intermission while you click the like and subscribe and watch a video of a beautiful bearded man blowtorching paint. Back to the testing. To prevent electrifying your brains too much, we'll just fill out 1 circuit. Let's look at sockets. I've already done circuit number 1, which is a heater. So, circuit number 2 of 3. Description: radial sockets, not rocket science. Reference method: if you were observant in part 1, you'll know that's method 103. Number of points: 21 last time I counted, but don't quote me on that. Conductors: well, the lives were 4 mil and the earth was 2.5. Protective device section is the breaker. As you can see, it's 16 amp with a breaking capacity of 6 kiloamps, and being a 60898 breaker is a max permitted earth loop impedance of 2.73 ohms. RCD is a 61008-1, 30 milliamp, A-type, rated at 63 amps. We're going to use a Q-Tech KT63, so let's fill in the juicy details of the test instrument up here for shits and giggles. Circuit 2, not a ring, so ignore that bit. R1, R2. Now let's play some pokey pokey with the probes. Link the earth, R2, and the line, R1, at the board in a connector block. Set the tester to continuity and head to the last socket on the circuit. Connect the brown and green cables to your tester, give her another little poke and see what she says. Okay, so R1, R2 is 0.59. Now, if we add that to ZE at dB, which, off camera, I'd already found to be 0.29 ohms, we get 0.88 ohms. And unless you're that really special kind of stupid, you should know that 0.88 is less than 2.73, so well within the permitted value for circuit earth loop impedance, ZS. For insulation resistance, we'll smash 500 volts down this bad boy, so you definitely got to make sure all your sex robots are unplugged. You don't want to fry their memory banks of advanced Kama Sutra positions. The warranty claim will be very awkward. Basically, this test checks if the electrons in your circuit are playing musical chairs with the wires. If you get a reading of less than 1 megohm, they're probably jumping around like a crackhead on acid. More than 2000 is best, but I wouldn't bat an eyelid at anything above a few hundred. Let's test line and neutral, or R1RN as the pros call it. Nice. It ain't over yet though. Now we go lives to earth. Lovely. Safer than a condom made of Goodyear tyre rubber. Now for the grand finale, the RCD test. According to the IET, we don't want to be electrocuted for longer than about 400 milliseconds during a fault, so let's make sure our RCD trips faster than a drunk dad at a wedding. First, remove the RCD locking device. Switch the circuit on and get your Q-Tech plug tester back in action. Plug into a socket, set the tester to RCD 30mA auto mode and press the magic button. The tester will then pump half, 1 and 5 times the tripping current down the circuit to see what your circuit protection does. When it tests at half, you want the RCD to stay quiet but attentive like a well-trained dog. But when it tests at 1 and 5, you want it acting like a nightclub bouncer and stopping electrons from entering the circuits. You'll have to reset the RCD each time it trips. Don't worry, you can recall the results after the test if you didn't have time to write them down. Lastly, press the test button on the RCD and we can tick that box too. Well, that's the testing done. Congratulations, your installation probably ain't going to burn your house or shed down. You can now register the results with an NIC and plug in and safely power up all your sex robots. Well, I hope you found that mildly entertaining. The only thing left to do is electrify that like button, continuity test the subscription button, share it with your favourite OAP stripper,
For an extra 50, I'll even take my teeth out.
and stay tuned for the next instalment of Fixing Rusted Stuff.